Next topic we are about to start is called as the deadlock. Let's try to understand what you mean by deadlock. The word itself, dead, lock. Lock can be understood as the weight which will ultimately cause death. So the term is called deadlock. Let's try to understand. Bookish meaning or theoretical meaning of a deadlock is endless wait. Now, how endless wait will cause deadlock or rather death? Let's try to understand. A process, let's say process X enters a wait period which will never gonna stop. It after waiting for a certain amount of time, it will enter something what we call as starvation. It's a period for which it is struggling to stay alive, and after the starvation period is over, that means if nothing happens and still starve, you will be finally dead. So endless wait causing death is a deadlock. The second question is obvious. Deadlock would occur in any system or in multi-processing system or what? Okay. To answer that query, we are making it very simple. Uni-processing system will never have issue of deadlock. Why and how? Let's try to understand. In uni-processing system, out of n available process, let's say process X, process Y, process Z. Process X will start, may request for a resource, let's say X. That resource gets allocated to it, and once it is used, it is released. Fairly simple. Only after process X is over, the next process PY enters the system. That means it will again repeat the same thing, that is request resource. Let's say this time again X only I am saying. It is allocated, it is released, and PY is over. Then the next one will enter. That means on a similar front, PZ request resource X, it gets allocated, it is released, and PZ is over. So basically in uni-processing system, since everything happens one after another, PX is first getting over, then PY, and then PZ. Now consider multi-processing system. What would happen? In multi-processing system, PX, PY, and PZ all will try to access resource X at the same time. Considering a luck factor that it is allocated to process X due to some reason, due to some calculation. Now till the time process X has acquired resource X, let's try to understand what would happen to PY and PZ. During this period of time, PY and PZ are waiting. This would become more troublesome because in multi-processing system, each process has mutual exclusion. Making one thing obvious, it won't be able to know who has resource and who would be going next after it. So the moral of the story is fairly simple. The problem of deadlock majorly arises in multi-processing system and not in uni-processing. This is because we can have multiple processes requesting for multiple resources and especially using a circular wait. Now what do you mean? We'll understand soon.